Section 8.7 is about infinite geometric series. So yesterday we learned about geometric series in general that ended at specific points. If we kind of go back to that lesson really quick, I can show you kind of like in the very beginning. You'll notice, and I made a mention of this yesterday, that this tells us this is where we're stopping, okay? N equals 8. That's how many terms we want, okay? For this one right here, we basically figured out how many terms by looking at those two numbers, 8 minus 1 plus 1, right? So it was a certain set of terms. This one right here, we had 8 because we subtracted 8 minus 1 plus 1. So yesterday's homework was all about finding geometric sums of finite geometric series, meaning we only wanted 8 terms, 10 terms, 20 terms, okay? Today's lesson is more on what if we don't tell you to stop and we want you to continue counting theoretically till infinity, right? Forever. You're going to keep counting forever. What is it going to want to add up to? Okay, by the time you're done counting like a million, a billion terms, right? What is it going to be adding up to? So those are called infinite geometric series. All right, so let's find the sum here. Let me give you guys a definition. So the sum of an infinite geometric series. So you'll notice something right away that's a little different. There's no subscript on the S. It's just the sum. In other words, just keep adding. Now, there are some books that actually do this. S sub infinity, meaning go forever. Okay, keep adding forever. I don't like to do that. It looks a little weird. So just the letter S means just keep adding. Okay, not S sub 5, not S sub 10, right? Because that means the first 5 terms, the first 10 terms, etc. We're just going to keep adding forever. Okay, and the formula is A sub 1 over 1 minus R. That's the formula. A lot easier than yesterday's, right? It's missing something from yesterday's, right? Yesterday's had the 1 minus R to the N on top as well, right? So we got rid of that. We don't need it anymore. Okay, so there is one thing that you guys have to be aware of. The absolute value of R must be less than 1. Whatever your R value is, you got to make sure that it's smaller than 1, because if it's smaller than 1, then we can find the sum. If it's not smaller than 1, then they say this diverges, okay, meaning it doesn't have a sum. It just keeps getting bigger and bigger and bigger. The number never stops. The thing is that we need our common ratio to be less than 1, okay? So let me just put right here, if the absolute value of R is less than 1, then it converges, and I'm going to highlight that really quick. It converges, which means it has a sum. Okay? So if the absolute value of R is less than 1, then it has a sum. If the absolute value of R is greater than or equal to 1, then it diverges. Okay? And if it diverges, that means that the sum is infinite. Okay, the sum is just huge, huge, huge. So we're going to say does not have a sum. And I'm going to put right here infinity. Okay? In other words, it just keeps adding up to a really large number, but we can't figure out what that number is. All right? So even though the formula is easier, there is a prerequisite to every problem. You got to check. And sometimes when you get your R value, let's pretend R is 2/3. Well, 2/3 is less than 1. That means I can actually use the formula. Okay? But if r is like 2.8, then, well, that's bigger than 1, so there is no solution to that sum, right? It's infinite. It diverges, okay? So if it diverges, or if it doesn't have a sum, then say it diverges. If it does have a sum, then we'll find it. Hold on one second. I feel like I'm going to sneeze, but nope, not anymore. So example number 1, they're gonna give you 3 types of problems in this homework. So here's example number 1. So as usual, they like to say evaluate the infinite geometric series. Maybe I'll just do ABC. That way I don't have to keep rewriting that instruction there. So we're going to evaluate the infinite geometric series, and here's the first one that we're going to try. Maybe I'll do this one. Now, they don't all look like this, okay? But I'm going to do this one on purpose here, just because this one looks like it can be a little difficult. Remember, you guys are allowed to use calculators. So don't let this freak you out. The fact that there's fractions. Okay. Now, can anybody tell me what the R value is? Because that's what you want to figure out first. Because once you know that, you can tell whether or not you should find the sum or if it can't be done. Does anybody know what the R value is? A 3? All right, there is a 3, but it's not 3, but there is a 3. Now, why did you say 3? What made you say 3? All right, so the denominator is a 3. All right, so we're getting there. Anything else you notice? It's negative because it's alternating, right? It's negative because it's alternating. Now, I heard someone say 7. If I put a 7 on top, that means I'm going to have to keep multiplying by 7 as well, right? So shouldn't the 7 go from 7 to 49 to whatever 49 times 7 is, right? It has to change, but notice the top stays consistent. What number do I multiply by in order for it to stay consistently the same? A 1. That's your common ratio. Now, if you're like, I can't do that in my head, remember, you can divide, right? Get your calculator, and I'm just going to do this in green as side work. Do 7 over 135 divided by negative 7 over 45, and you'll notice it's going to give you a negative 1/3. Or you can try negative 7 over 45 divided by a 7/15. That'll give you a negative 1/3. Or 7/15 divided by negative 7/5. That'll give you a negative 1/3. So basically, I just divided everything like here to here, here to there to there, just to make sure, right? And all my answers will come out to a negative 1/3. So that's my R value. So if you couldn't like think your way through it, you can just get your calculator, divide, okay? So you can find your R value. So is it true that the absolute value of negative 1/3 is less than 1? Is that true? I mean, the absolute value of a negative is just positive. Is it true that 1/3 is less than 1? Yes? No? Yeah, it is. 1/3, right? 0.33333. Since this is true, then I can do my sum. Okay? This is the part, like I said, that's a little different. We never had to check before. But now we got to check the R value before we actually do anything. All right, so here we go. Here's my formula. I'll write it down. A sub 1 over 1 minus R. All right. So A sub 1 is what? What's my first term? Negative 7/5. All right. Negative 7/5 divided by 1 minus, and my R value is negative 1/3. All right. So I got the negative 7/5 from there. I got the negative 1/3 from there. Okay, my first term is negative 7/5. My R term is negative 1/3. By the way, if you're wondering, like, this doesn't look that easy. Remember, I'm picking a tough one to start. Okay, right now we'll do another one that's a little easier. But I just wanted you guys to see one that's kind of on the tough side. But remember, you're using a calculator, so don't freak out. Okay, you don't have to like do all this stuff in your head. Just write it out. Use your calculator. I'm going to simplify the bottom really quick. Negative 7/5. 1 minus a negative 1/3. That's 1 plus 1/3. That's 4/3. So whenever you have a fraction divided by a fraction, you multiply by the reciprocal of the bottom fraction. Okay, I can't simplify anything. I can't cross cancel or anything. So that's going to be a negative 21 over 20. That's my sum right here. That's what it adds up to. Negative 21 over 20. Right now we'll do an easier one, okay? But I wanted you guys to see like when I look at the homework, I look at it and I say that one's probably the toughest one. So let's do that one first, okay? Right now we'll do one of the easier ones, not from your homework. I'll just make one up right now. But we'll do an easier one so you can see how easy they can be too, okay? But main thing here, guys, calculator work, right? That's what we've been talking about all chapter 8. You're going to have to use a calculator for most of this stuff, okay? I mean, you don't have to, but it's helpful, okay? It's definitely helpful. So just to recap really quick, we got the original problem. The first thing you had to do was figure out R. You could either do that in your head, or you can do what I did on the green side and just divide all the terms really quick, right? And that's going to give you your negative 1/3 as well. So you know that your R is negative 1/3. Then you have to test it. Is it true that the absolute value of negative 1/3 is less than 1? Okay? If it is, then you can continue. If it isn't, then you're done and you say it's divergent. It doesn't have a sum. Okay? But since this one was true, so I put a yes right there, right? I had to do this work. So I wrote out my formula. My first term, remember, was in the very beginning of the problem. My R value, we figured it out. I plugged it in. And then from there, it's just using a calculator if you want to get your answer. You don't have to do it by hand like I did. And I got negative 21 over 20. All right, so let me give you one more like this that is not from your homework. So we'll do like 3, 9, 27, 81. Nope, I don't like that. I don't like that. Hold on. Let me write them backwards. If I write them backwards, that'll make me happier. If I leave them like that, there's no sum, and we'll talk about that really quick. But write them like that. Write them backwards. 81, 27, 9, and 3, etc. Again, notice how this thing puts the ellipses, right? Dot, dot, dot at the end, but it doesn't tell you how many terms. It just says dot, dot, dot. That means it's infinite. It keeps going forever. Okay? All right, so what is my R value here? It's, well, 81 times what is 27? 27 times what is 9? 9 times what is 3? If you can't do it in your head, remember, divide. 3 over 9, 9 over 27, 27 over 81. What do we get? Try them out. Do it on paper. I'm going to rewrite these in black. I just realized I put them in red. So B, 81, 27, 9, 3. If you can't do it in your head, remember, do it by hand. So 3 over 9 is 1/3. 9 over 27, 1/3. 27 over 81, 1/3. So what's my R value? It's 1/3. Is 1/3 less than 1? Yes. Okay. That means there's a sum, so I have to do the work. I have to do the work. All right, so S is equal to A sub 1 over 1 minus R. What's my A sub 1? 81, right? I got 81 right there. So 81 over 1 minus 1/3. Again, use your calculator so you don't have to do what I'm about to do. So this is 81 over 2/3. Because 1 minus 1/3 is 2/3. You're going to multiply 81 times 3/2, right? We got to flip the fraction. Okay. So what do I get here? It's not going to go evenly. 3 times 81, that's 3 and 24. So 243 over 2. That's my answer. 243 over 2. I don't know what that is exactly, but 121.5. Okay. So, but I'm okay with the fraction answer. You don't need to write it exactly. So, what would it look like if it failed? If it didn't work? Well, let me just kind of do it on the side right here. The way I wrote it at first, that's why I didn't want to do it. What's your R value for that one? 3. And is 3, the absolute value of 3, less than 1? No. So then you say diverges. Okay, like no sum. I'm just going to put right here like no sum. Okay, so if the problem doesn't work, that's pretty much all the work you have to put into it. You're going to find R, and if you realize that R is not less than 1, then you're going to say, no, it doesn't work. I'm done. That's it. If it does work, then you have to do the stuff on the left side, the red part, where you got to find the sum. Okay, so formula is easy to use. Like I said, it's just you have to find the R value and test it. Okay, so like I said, there's a couple ways that they're going to make you guys do this work. Now, the second way I'm not going to show you. The reason why is because the second way they literally give you A1 and R. Like there's no set of numbers. They say A1 is 5, R is 1/2. Okay, what the heck? I'll just show you anyway. It'll be quick because there's no thinking involved in this one. I just made up a problem here and we'll just use it. So there's going to be some problems where they're just giving you that. 6 of them that they're just going to give you that straight up. Okay? We know that my R value is 1/2. Is it true that the absolute value of 1/2 is less than 1? Yes. So that means I can do the work. So S is equal to A sub 1, which is 5, over 1 minus 1/2. Well, 1 minus 1/2 is 1/2, so that's 5 over 1/2, which comes out to 10. And there's your answer. Remember, it's not 1/2 of 5, it's 5 divided by 1/2. So the 2 is going to flip over. 5 times 2 gives you 10. So you have like 6 problems like that, where they're just going to give you A1 and R, and they're going to say, can you do it, yes or no? If you can, do the work. If you can't, say diverges, can't do it. All right? The last set of problems that they're going to give you are going to look like this. Did I put B on that one? It should have been C, right? Yeah. Let me put a C on that. And this is going to be the last one, part D. As usual, they like to throw in something with sigma notation. But you're going to notice something kind of interesting here. And I'm writing it the way your worksheet's going to have it. Notice how you know that this is an infinite series is they have infinity as your finishing point, right? The bottom number on that sigma is supposed to be where you start. The top number is where you end, but notice the top number is infinity. In other words, you're not ending, you're going forever. Okay, that's how you can tell that this is an infinite geometric sum when you're doing sigma, because of the fact that this says infinity. Okay, it doesn't say like 10 or 12, 20, right? This is saying go forever. All right. So knowing that, what's my R value? 2.1, right? 2.1, it's this, it's right there. They just don't put the parentheses, okay? But it's right there. Now, is it true that the absolute value of 2.1 is less than 1? No. So then what do I say? Diverges, and you're done. Okay, just diverges. There's no sum. Now, if it was something less than 1, then I would just use the formula. Okay? It doesn't matter whether it looks like sigma or a sub 1 in R or a set of numbers. It doesn't matter. They're all done the same. All right? So this is what your homework is. It's a total of 14 questions. There's 4 of these sigma notations. There are 6 of these notations. Okay, and the rest of them, the other 4 are like, they're like this. Okay, so I'll go back to the bottom problem now in case you're copying it down, but just so you can see, it's not a lot of work to do these things. I think it takes longer to write them down sometimes. So let me pause this here.